Angles and segment relationships in circles. There are a bunch of different properties we're going to look at. I would take notes. First one, if a tangent and a secant or chord intersect in a circle at the point of tangency is B right here, measure of the intercepted arc. So this angle here would be half of that arc. If this was 100 degrees, then this angle ABC, would be 50 degrees. We could also go the other direction with that. If I told you that this angle was 55 degrees, then I know the arc would be twice that. The measure of arc AB would be equal to twice that, 110 degrees. In this example, we have two tangents, AE and HJ, and we're going to be given one angle or arc, and we need to find the other angles or arcs. In this question, we're given that the measure of AHJ is 52 degrees, and we know that this angle is half of the arc, which means the arc is twice as big. If this one is 52 degrees, the arc is twice that, it's 104 degrees. There are only 360 degrees in a circle, so then we know that from here clear around to here is the rest of the circle. It's going to be 360 minus 104. That's 256 degrees. So that other arc, it's a major arc because it's more than 180, is 256 degrees. Now notice how EA is also a tangent, and right here that angle would be half, the angle formed with a chord would be half of the arc it cuts. That's half of 256, which is 128 degrees. So the measure of AH is 104 degrees. The measure of angle EAH is 128 degrees. And the measure of arc HNA, that's from here, here, and here, all the way around, is 256 degrees. Our second theorem says that if two secants or chords intersect in the interior of a circle, then the measure of each angle formed is half the sum of the measure of its intercepted arcs. This angle here, or this one, these are vertical angles, is half the sum of these two arcs. Notice that that's an average. Add them up and then divide by 2. Multiplying by half is the same as dividing by 2. Look at the picture again. This angle, or this angle, is half the sum of the intercepted arcs. Which, by the way, means that if you want to find this one, you know that that's a linear pair. If I find angle 1, I could subtract from 180 and get that angle on the other side. And then these two angles, above and below, would be vertical angles, and you would have them both. Here's an example of that theorem in action. If I'm going to find this angle right here, or this angle, I just add up the two arcs, 140 plus 92 degrees, and divide by 2. That is 116 degrees. If I need to find this angle, I'll use the fact that these two are a linear pair. I'll take 180 minus 116, and that is 64 degrees. So this one's 64, and this one is 64, and these two are 116. We're looking for XFT, that angle, XFT right here. It's 64 degrees. This theorem is often mixed up with the previous theorem. The previous theorem, when the chords intersect, the angle formed is the average of the two arcs. This is not an average. Notice that you're also dividing by 2, multiplying by half is the same as dividing by 2, but you're subtracting them. It is not an average, so don't mix the two up. The previous one, yes. When the chords intersect, that angle is the average of the two arcs. This one's not that way. You actually take the big arc minus the small arc and divide by 2. Let's read the theorem. If a tangent and a secant, two tangents or two secants, it's all the same, they intersect in the exterior of a circle. We're talking about at point C or point F or point L. Then the measure of the angle formed, that's this angle here, angle 1, 2, or angle 3, is half the difference of the measures of the intercepted arcs. Take the big arc, subtract the small arc, and then divide by 2. The questions I've given you on this are a little trickier because I might ask you to find any one of the three. You might be asked to find the angle, or this arc, or that arc. It's going to be random. Every question, however, is set up the same. If this arc, xt, is 138 degrees, and the angle is 42 degrees, let's call this x. That's the big arc here. I take the big arc minus the small arc, 138, and divide by 2, and that's how I get that angle, which is 42 degrees. If I was solving this, the first thing I would do is multiply both sides by 2. That will allow me to cancel those 2's. X minus 138 equals 84, and we'll add 138 to both sides, and x will equal 222 degrees. Here we have a secant and a tangent. Take the big arc minus the small arc, divide by 2, and you get that angle. We know that the measure of angle J, that's that angle there, is 48.5 degrees. We know that FO is 49 degrees. Let's call this X. We take X minus the 49, and we divide by 2, and that gives us 48.5. We'll multiply each side by 2 to get rid of fractions. Cancel. X minus 49 equals 97. And we'll add 49 to both sides. 97 plus 49 is 146 degrees. The previous example was two tangents. Here we have two secants. It's set up exactly the same way. Big arc minus the small arc divided by 2 gives you that angle. We know that here NX is 50 degrees, that HF is 89 degrees. To get the angle O, we take the big arc minus the small arc and divide by 2, and that would be the measure of angle O. That ends up being 19.5 degrees. Our next theorem is the chord-chord product theorem. This is kind of a cool theorem, and it actually is easy to prove. If you draw in CA and BD, it turns out those triangles are similar because angle ACD is an inscribed angle. This angle is half of that arc. And if you look at different color here, angle ABD, this angle here is an inscribed angle. It's also half of that same arc. Those two angles are congruent. And then we have vertical angles. We have angle-angle similarity. We have two angles congruent and two triangles. And then this is just the cross multiplication and ratios with similar triangles. Let's simplify this a little bit. Notice the two chords where they intersect. Call this A and this B and this C and that one D. what this theorem is saying then here is that A times B is equal to C times D. Isn't that a cool relationship? In this diagram then, we could say that 5 times x is equal to 6 times 12. You just divide both sides by 5, you get x by itself. And we're going to round to the nearest tenth. Looks like I need to add that in the directions. We get 14.4. This is the secant-secant product theorem. And what it says is that when you have two secants that intersect in a point, that the relationship formed is that if you take the whole length times the outside piece, it would be equal to the whole length times the outside piece. AE times BE equals CE times DE. Again, whole length times the outside piece equals the whole length times the outside piece. Again, this is from similar triangles. In this example, HN is 5, HR is 4, NC is 9, which makes this whole length 14. And we're going to find RY. This is our X. If RY is X, the entire length then, HY, would be 4 plus X. The theorem says when you have two secants that intersect like this, that the whole length, 14, times the outside piece, 5, equals the whole length, 4 plus X, times the outside piece, 4. 5 times 14 is 70. I'll distribute here, take the 4 to both. 4 times 4 is 16, plus 4x. Subtract 16 from each side. 54 equals 4x. And divide by 4. 54 divided by 4 is 13.5. This is our last relationship, our last theorem. It is the secant-tangent product theorem. Remember the previous theorem said that the whole length times the outside piece equaled the whole length times the outside piece. The issue here is we have one tangent, not two secants. The relationship is very similar. The whole length times the outside piece equals the tangent squared. Notice how there isn't two pieces with the tangent, which is why it's squared. In this example, the way it would work is the tangent is squared, LV squared equals the whole length, that's JV, times the outside piece, which is PV. 2 root 15 squared then equals the whole length, which is x plus 6, times the outside piece, 6. Now you might think this is complicated, but actually it isn't. You're going to square them both. It's going to be 2 squared and 15 squared under the square root. Over there we distribute. This is 4 times 15. The square root of 15 squared is 15. A square and a square root right here, they're inverses of each other. They cancel each other out, which is why it ends up being 4 times 15. Notice that we had to square the 2 though. 4 times 15 is 60. 60 equals 6x plus 36. We'll subtract 36 from each side. And 60 minus 36 is 24. 6x equals 24. And if we divide by 6, x would be 4. 24 divided by 6 is 4. The rest of this video is questions from your assignment. I already did an example of each question, but if you have trouble, I did one of each type, and go take a look at it and watch, and I'll explain each one again. Question 10. Two chords intersect here. The angle formed is the average of the two arcs. That's this angle or that angle, the arcs that are intercepted. 137 plus 130 divided by 2 will be what those two angles are. This ends up being 133.5 degrees. We'll erase this and put that in there. 133.5, 133.5. I know that I have a linear pair right here. I can subtract from 180. 180 minus 133.5 is 46.5. This angle is 46.5 degrees, and this angle is 46.5 degrees. What do we ask for? HWY. HWY. It's that one. 133.5 degrees. Question 13. When we have two secants from a point that pass through a circle, the angle formed is the difference, half the difference of the two arcs. We take the big arc minus the small arc and divide by 2. Notice this is not the average. EH is 50 degrees. PW is 96 degrees. This angle, the measure of angle L, is the big arc, 96, minus the small arc, 50, divided by 2. And that is 23 degrees. Question 15. This is exactly the same as the previous example. We had two secants in the previous. This is a secant and a tangent, but it's the same theorem. The angle formed is half the difference of the two arcs. The measure of angle A here is 50.5 degrees. BV is 136 degrees. I'm going to call that X. 136, the big arc, minus the small arc, divided by 2 is 50.5. Let's get rid of fractions. Multiply both sides by 2 and cancel. 136 minus X is 101. Subtract 136 from both sides, and negative X equals negative 35. Divide by negative 1, and X equals 35. So arc YV is 35 degrees. Question 17. The angle formed by a tangent and a chord, or a secant, that intersect at a point, the tangent point, is half the measure of that arc. The measure of angle VRZ is 50.5 degrees, which means the arc is twice that, because the angle is half the arc. So the arc is twice that. So I'll double 50.5 and I get 101 degrees. We can find this major arc right here by subtracting from 360, because the two have to add to 360 and make a full circle. 360 minus 101 is 259 degrees. This angle, that's a tangent again, and a chord, the angle is half of the arc. We're talking about that arc right there. Half of 259, or 259 divided by 2, which is 129.5 degrees. So the measure of VR, the arc, is 101. The major arc, RBV, was 259. and the measure of angle NVR was half of that arc. It was 129.5. Question 23 is the chord product theorem. It says that x times 11 is equal to 12 times 8. 11x equals 96, and we'll divide by 11, and I added directions, so round to the 10th. 96 divided by 11 is 8.7. Question 25. This is very much like the theorem that with two secants. It says that the whole length times the outside piece equals the whole length times the outside piece. The issue is there isn't two pieces in this top segment, which is why it's squared. The theorem says that TO squared would equal the whole length LO times the outside piece WO. X squared would equal the whole length is 27 times the outside piece 15. That is 405. I know that 27 is 9 times 3. 9 is a perfect square. I'm just looking at my factors here. 15 is 3 times 5. Now look at that. 9 is a perfect square. 3 times 3 will make one more perfect square. And 9 times 9 makes 81. 81 divides into that. When I take the square root of both sides, I know 81 divides into 405, so I'll divide 405 by 81, and I get 5. The square root of 81 is 9. 9 root 5 is the answer in simplest radical form. Question 28. Related to the last example, this one says that the whole length times the outside piece equals the whole length times the outside piece. Two secants. This is 7, and EZ and EW is 6. WX is 16, which makes the whole length 22. We'll call this X. This is 7 plus X. The whole length, 7 plus X, times the outside piece, 7, equals the whole length, 22, times the outside piece, 6. Distribute, 49 plus 7X equals 132. Take a 49 off each side. 7x equals 83. Divide by 7, and we're rounding to the 10th. X is about 11.85 to the 10th. That would be 11.9.